Good morning, Honors Algebra 2. We are starting a new chapter. We aren't testing on the last chapter. We're just going to do quizzes from here on out. We are moving ahead. If you read the notes on this, you'll see that I am moving to chapter 12 from chapter 7. I'm getting the important information to you that you'll need for next year. And chapter 12 is all about sequences and series. The things that we'll have to know are what the terms are. So the terms are the values in the range. Now the range are the y values, they're the output values. So whatever is happening to the function, the range would be the terms. Now what is a sequence? A sequence is a function whose domain is a consecutive set of integers, which means we're inputting a consecutive integer to get the first term, then the next one to get the second term. Consecutive means following each other. A finite sequence is a sequence with a limited set of terms. It ends, finite, finishes. An infinite sequence is a sequence that continues without stopping. Give you a few seconds there. This might not be as easy to see. When I go to print on my printer at home, it condenses things and makes them look different than what it does on the actual paper because I'm sending it from my phone. Okay, example number 1, we have the nth term. This is what generates the sequence right here. This is generating the sequence, and I want to find the first 6 terms in this sequence. So what I'm doing is I'm finding a sub 1, a sub 2. These are just names for the terms. They just give them names. So for example, a sub 1 means everywhere I see the n, I'm going to put a 1. It's just like a function. So this is going to be 2 times 1 plus 1 is 3. This one is going to be 2 times 2 plus 1 is 5. And you can see what's happening is every term that we do the next one, we're adding 2. So this is going to be 2 times 4 plus 1, which is 9. And you can just about guess that this is 11 and this is 13. So this sequence would look like 3, 5, 7, 9, 11, 13, 15. Kind of like that, but yeah, like that. Very similar to that. Now we can also have a sequence that's written in terms of a function. So this one is saying we are going to take -2 and raise it to the 1 minus 1. One minus 1 is 0. Anything raised to the 0 power is 1. So this is going to be -2 raised to the 2 minus 1. That's going to be to the first power. So -2 to the first power is -2. When we plug 3 in here, we're going to have -3. Oops. Wait a minute, -2, I apologize for that. -2 to the 3 minus 1. So that's going to be -2 squared is 4. This next one is going to be -2 to the 4 minus 1. So that's going to be -2 cubed, which is -8. Now I want to show you what's happening here is the signs alternating. So this one's probably going to be positive. So it's going to be -2 to the 5 minus 1. And that'll be -2 raised to the 4th power. That'll be positive 16. And this one is going to be a negative because it's an odd exponent. 6 minus 1 is 5, so this is -32. When you have a negative being raised up to a power like that, more than likely it's going to alternate signs. 1, -2, 4, -8, 16, -32. So the next one would have been positive 64. So there's a pattern involved. when you're trying to find out what the pattern is, when you have the sequence, what you need to do is go up above and assign these little whole numbers, the consecutive numbers, and try and figure out what is happening to 1 to get 3, to 2 to get 1 to get 1, 2 to get 3, 3 to get 5, 4 to get 7. What are we actually doing to that? And can I'm almost treating you like you're in the classroom. Can anybody tell me what the next one is? The next term would be 9, and that's what it's asking us, the next term. The next term is definitely 9. Now this might be a little bit tricky for some people to see, but if I take 2 times 1 minus 1, I get 1. It's working it a little bit. It's trying to figure out, it's kind of like a chess game. What did I do to get to here? What do I need to do to get to here? If you look, if I plug 2 in, I get 4 minus 1 is 3. If I plug 3 in, I get 6 minus 1 is 5. 4 in, I get 8 minus 1. So that's how that worked. Okay, let's take a look at this one. This one is all right. Plug a 1 in here, 2, 3, 4, 5. And if you look, what's happening is every other one's negative, so I know that my next answer is going to be negative. And what am I doing? Well, it looks to me like anytime you want to alternate the negative, this is kind of tricky. You raise -1 to the n power, and that's going to help you with that. This is not the problem that I thought it was supposed to be. Okay, so this problem is not the one that I was going to use. Because this one doesn't quite work out the way I wanted it to. All right, so let's go ahead and skip this one, and I'm going to put another one up here that I really wanted to do. -4, 8, -12, 16. I still need that -1 to the n too, because if I raise that to the first power, that'll give me a negative. I raise it to the second power, that'll give me a positive. So I'm going to leave that there. But this is, if I put a 1 here, a 2 here, a 3 here, and a 4 here, I'm multiplying each of these by 4. So this is going to be 4n. That takes care of the numbers. 4 times 1, 4 times 2, 4 times 3, 4 times 4. And this -1 to the nth power, that's how we're going to go ahead and start with a negative. Now, if we wanted to start with a positive, starting with a negative, we use this. But if we want to start with a positive number, let's say that this was 4, -8, 12, -16. Instead, we would have 4n times -1 to the n plus 1. Or it could be n minus 1. It would still work, but not the n. Now we want to find out what generated this. So this is our answer here, and this was our answer here. So if this was 1, this was 2, this was 3, and this was 4, what do we have to do to each of these to get these? Well, we know we need a negative, and it's 1 across the top, so it's going to be 1 across the top. How do we get to 2 from 1? How do we get to 4 from 2? 3 to 6, we're doubling it. So this would just be 2n. And that will generate all of that. And what is the next term? Ooh, we forgot to do the next term for this one. What's the next term for this one? It's going to be -20. And what is the next term for this one? It's going to be -1 over 10. That's the next term. Now let's see what generates this. We have a 1, 2, 3, 4, 5. We don't have to worry about signs. They're all positive. And if you'll notice, these are all the same thing. So that's just going to be n. And in the bottom, it's just a 3. And the next term would be 6/3. Now you'll notice that that is not changed to 2 because it would be hard for us to see what is happening in this sequence if we were to change that 3/3. That is a 3, by the way. If we were to change that to 1, it might be harder for us to recognize what's happening. Hope everybody's doing fine. Take care.